In this lesson, we're going to talk about rational expressions. First of all, what is a rational expression? A rational expression is of the form p divided by q as a fraction, where p and q are just polynomials and q cannot equal to 0. Because think about it, if my denominator is equal to 0, then my expression is no longer going to be defined. We're going to talk about that in a little bit. For now, let's just look at what is a rational expression. What does it look like? Well, it's just one polynomial being divided by another polynomial. Remember, polynomials are expressions that have variables with positive integer exponents. So when I look at my denominator of this first fraction here, I have 3x. That's a polynomial. In my denominator, I have x to the fifth minus 3x plus 9. Again, another polynomial. My variables have positive integer exponents. So this first one is a polynomial. The second one, I have the absolute value of x. Well, right there we could stop. Absolute values are not polynomials. In our third example, I have 3 minus 4, the square root of x. Again, we could stop right here. Square roots are not polynomials. So this is generally what we're going to see for a rational expression. One polynomial over another polynomial. And those polynomials could have any number of terms. It really doesn't matter as long as it's a polynomial. Let's go back to the idea of having q not equal to 0. We know when my denominator is equal to 0 that the expression is undefined. Sometimes we want to know when that expression is undefined. And when we start talking about functions, that's when it's going to be more important. But for now, let's keep it simple. Let's find the values of the variable where my expressions are undefined. Well, in order to find that, we know that means the denominator has to be equal to 0 in order for an expression to be undefined. So I'm going to take my denominator and set it equal to 0 and solve that equation. So for this first expression here, x equals -2 is what makes the expression undefined. When you plug in -2, we get -2 plus 2, which is 0. So -2 makes that first expression undefined. The second expression is x squared minus 4. Well, that's a difference of two squares, so we can factor that into x plus 2 and x minus 2. Using our zero product rule, x plus 2 equals 0, x minus 2 equals 0. So we have two values that make this expression undefined. X equals -2 and x equals +2. Notice how we could care less what the numerator is. It does not matter what the numerator is. All we care about when we're looking for where a rational expression is undefined is where the denominator equals 0. Our last example, we have x squared plus 9. Well, this doesn't factor, this is prime. So let's think about what value of x we would need in order to get 0 as my answer. Well, if I take any number, any real number, positive or negative, and I square it, what's going to happen to that number? Well, it's just going to end up being a positive number. So if I put a -1 in there, I'm going to get a +1 back. If I put a +1 in there, I'm still going to get a +1 back. So x squared is going to take any number and make it positive. When I add 9 to it, I'm just making a larger positive number. So this expression is defined for all x, meaning there's no number that x could be that would make the denominator equal to 0. And that's the basics for rational expressions. In the next videos, we'll talk about the different operations that we can do on rational expressions.